Alrighty, everybody. I just got the okay to start our planetarium show, so I'm gonna put away our space trivia questions up on the screen because now we're gonna be heading into the unknown. Ooh. And once again, everybody, welcome to the Morrison Planetarium. I am pleased to have y'all here with us today. I just want to let you know really quickly or introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls, I'm actually a person and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward to the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one enormous screen, thanks to the help of six different projectors hiding throughout our planetarium dome. And to let you know, folks, everything that you're going to see on this big screen is backed by scientific data, evidence, peer review, critique. So we love to be as scientifically accurate as possible. And to tell you folks, the show that we're going to be doing right now is one of my personal favorites to do by far. This show that we're going to be doing is called Tour of the Universe, and this show is completely live. What that means is that you're going to hear my voice for the next 30 minutes. I'm going to be free flying with our awesome space software, and pretty much the whole gist of the show, we're going to be starting off pretty close to Earth, and we're going to be zooming out to the very edge of the observable universe. Just a heads up, we are very small in the grand scheme of things. So if you have an existential crisis at the end of the show, that's totally normal, but just prepare yourself. And before we get started with our show, folks, I do got to go over some quick house rules just so that we're all on the same page and have a great time in the planetarium. There's a few of us in here right now. First off, there's no food or drinks allowed inside. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater clean for all of our guests coming in today. We came into nice, clean seats. We want to make sure those are clean, stay clean. Also, folks, if you happen to have any fancy 21st century gadgets like cell phones, smartwatches, tablets, anything that produces bright white light, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes, as these can be very distracting, not only for you, but for the folks sitting behind you in the planetarium, because this room's going to get quite dark. Having a really bright white light is very distracting. So make sure those are put away till the end of the show. And also, folks, if you do need to head out early during our show, need to exit early, the exits are going to be at the very top of the planetarium. So when in doubt, always make your way up the stairs, not down the stairs. You always want to go up the stairs. And folks, if you have trouble climbing the stairs, don't worry. Once the show's over, we'll have a staff member escort you to some lower exits. So just stay seated. Once the show's over, we'll help you out. And one last thing, folks, before we get started, this show is very immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to feel motion sensitive, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite you all, sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to home, but we're not exactly at Earth. We're a little bit just above our planet Earth. We can see the Earth just down below us. In fact, let me tilt this over. You can see all the city lights pop up in the dark down below. Actually, we're hovering just above India right now. So these are all the city lights of India popping up. And we're going to be starting off a little bit higher, as I mentioned, at this really cool spacecraft called the International Space Station, or we also like to abbreviate it as the ISS. Now, a lot of people tend to ask me, hey, Christian, what's the International Space Station? I hear about it all the time in the news and articles, but I don't really know what it is. Could you explain it for me? Well, don't worry, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth. How this came to be? Well, a bunch of nations, a lot of countries across planet Earth wanted to figure out what happens to things in space. So they all came together, created this really cool spacecraft. And so they get to test out different stuff that they wouldn't be able to on planet Earth. Some of the different types of science experiments that they'll conduct up here are things like, ooh, what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? What happens when you try to light a match in space? Does the flame act the same? Does that act differently? And one of my favorites is where they had two identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compare and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also tend to lose a lot of body mass index, a lot of muscles, because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, make sure to exercise daily. And folks, right now the International Space Station looks really large on our planetarium screen, but it's not that big in actuality. It's only about the size of an American football field. So if you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's about how big this spacecraft is. And to let you know, folks, right now during our presentation, there's about four astronauts that are docking onto the International Space Station as we speak. So right now, astronauts are pretty much docking the International Space Station. Three of them from the United States, one of them from Italy, and two of those are vets, and two of them are rookies. So now there's a total of 11 astronauts on the International Space Station as of today. And folks, what's really amazing about the International Space Station is that this thing is going incredibly fast. The ISS goes at a whopping speed of 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this is the International Space Station isn't too far away from the Earth either. It's only about 225 miles above the surface of our planet. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. But this is as far as we put humans out into space, only 225 miles above the planet of our Earth. The reason why? Well, it's very, very expensive. First, you got to build yourself a rocket ship or build or buy yourself a rocket ship. And then once you acquire that, you need to account for all the rocket fuel, and you're going to need a lot of rocket fuel. And once you get your hands on all that rocket fuel, you have to account for all the food, water, and all the air you're going to be breathing up here. So the bill gets really costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So let's slowly leave it behind. We're going to see the ISS slowly disappear compared to the Earth down below. And before we lose track of it, I want to add a nice little orbital path so we can see where it is as it slowly fades away. Alrighty, folks. So now we're looking down at our planet Earth, and I want to let you know, folks, that the space program that I'm using here in the planetarium is something you can go home and download if you like. If you want to fly through space just like how I am, the space program that I'm using is something called OpenSpace. So again, our space program is called OpenSpace. And if you want to download this, go to your favorite search engine, type in OpenSpace Project. You'll find the website where you can download it, and it's a whole lot of fun. But just a heads up, folks, this program is not finished. It's in its beta phase. So we may come across a few bugs and glitches here and there. If we do, I'll point them out. Hopefully, we can look past them. And also, folks, if you have an older computer, I wouldn't recommend downloading the program because it may overwhelm that older computer. This program uses a whole lot of processing power and information. So if you got a newer computer or a gaming computer, give it a try. It's a lot of fun. But if you're also a person kind of like me who doesn't really want to download anything, I really don't really know how to download stuff. There's also another great space program that you can use called NASA's Eyes. So just like the human eyeball, go to your favorite search engine, type in NASA's Eyes, and you can fly through space without having to download anything. So we have two awesome space programs, OpenSpace and NASA's Eyes. But let's leave the Earth behind because now we're going to be making our way over to our nearest natural neighbor to us in space, the Moon. Now, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had fun. They got to play some golf up here as well. And luckily for us, folks, we are inside the planetarium, so I have some special abilities. Let me turn off the nighttime on the moon. Hey, that looks much more familiar. Good to see you, moon. But again, folks, last time we humans have been to the moon was 1972, a little more than 50 years ago or so. But don't worry, we humans are planning to make a return back to the moon in the next few years, thanks to NASA's new space mission called Artemis. So, with NASA's mission Artemis, they want to send humans to Mars, but before we send humans deep into our solar system, we need to figure out the logistics, how exactly we humans are going to live out here in space. So, the moon is the perfect stepping stone to figure out all the logistics, all the stuff, how we're going to do that. But what's also really cool about Artemis is that they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has improved a lot in the past 50 years. So we're able to conduct different types of science experiments that we weren't able to 50 years ago. And a lot of that stuff, the equipment has gotten a lot smaller. So we can bring more stuff with us as well. And they're going to be setting up different lunar bases throughout the moon. Maybe they want to set up a base near Copernicus crater, which we're looking at right now. Maybe they'll set up a base inside or on the outskirts. Maybe they want to go take a look at some lava tubes that they weren't able to take a look at before. Or one place that we definitely want to take a look at is the south pole of the moon, because that is the location of the largest impact site in the solar system. And it's a lot easier to get material deep down in the moon when there's already a massive impact site. You don't have to bring a big tractor with you to dig a hole. That hole's already been dug thanks to that asteroid. And what's also really cool about Artemis is that they're going to be setting up, they're going to have a space station orbiting around the moon at all times, kind of like the International Space Station that we just saw. So if anything was to go wrong while these astronauts were on the surface of the moon, they can launch off the surface of the moon and head to that space station where they would be safe. So again, we humans should be heading back to the moon in the next few years. Crossing my fingers, hopefully everything goes according to plan. But look out for any news about Artemis in the coming years. And folks, when we look at the moon here on planet Earth, sometimes the moon feels so incredibly close to us that it feels like you can reach out your arms and touch it. It feels that close. But the moon is really, really far away from us. The moon's roughly about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick, because at this scale, using miles is kind of like using inches to describe the distances between cities, because space is so large. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye bye, moon. We'll see you later. And on our journey, folks, we're going to be stepping into a much larger realm of our solar system, because now we're going to see the moon and the Earth as they slowly disappear. In fact, before we lose sight of them, I want to add some nice planet trails so we can keep track of all the stuff out here in space. And on our journey today, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace that's showing us the most accurate and information available to us. And now the nearest star to us, the sun, comes into view. So there's the sun right over there. And folks, the sun is really, really far away from the planet Earth. The sun's about 93 million miles away from our planet. So 93 million miles away, that is a good distance. So again, we're the third rock from the sun. That's us right there, 93 million miles between us. But in terms of the speed of light, that's not that far at all. In order for light to travel that distance, it only takes light about 8 minutes and a half to cross that 93 million miles. Now, that's a really cool concept to keep in mind, because let's say the sun was to turn off all of a sudden, there was no more sunlight being emitted. That last bit of sunlight would travel that 93 million miles, 8.5 minutes, and then all of a sudden the daytime here on Earth would become nighttime. Now, again, this is a really cool concept to keep in mind, because this works for really far away objects as well. Let's say we're looking at a star in the background that's 70 light years away from us. Well, we're seeing that star as it looked like 70 years ago, because that light that just reached us took 70 years to get to us. So when we look at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye perspective of our solar system, let's take a quick look or a refresher of all the things in our solar system. There's a lot of cool stuff here. So right in the middle, we have our star, the sun, and then the closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if we were to highlight all those asteroids in the asteroid belt. There is a lot of them. Give them a second. There we go. Now, what's really neat is that the asteroid belt was discovered or came across by a European organization in the early 1800s. And this organization called themselves the Celestial Police, which kind of sounds like something out of Doctor Who, in my opinion. And then past the orbit of our main asteroid belt, we have the really big planets, the gas giants. We've got the Jovians, we've got Jupiter and Saturn, and then we have our icy gas giants, Uranus, the funny one, and Neptune. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto at the very top. There it is. And a lot of people tend to ask me, hey, Christian, why did Pluto get kicked out of the Planet Club? I love this place. I learned a bit about it as a planet when I was growing up. I still think of it as a planet, but why does everyone call it a dwarf planet? Well, you see, folks, Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt's going to be all this stuff. So again, this is the Kuiper Belt where we're looking at, and you can kind of think of it as a second asteroid belt. What you're going to find out here are mostly icy asteroids and short period comets that don't stray too far away from the sun. They have a nice little short period. But in 2006, some astronomers found more than 400 objects out here, and some of this stuff was way bigger than Pluto. So we can't call all these things planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And one of the criteria is that you need to be so big and so massive as an object that you push all the other things out of your orbital path. Unfortunately for Pluto, it dances around its moon Charon and gets pushed around by some other objects. So that's why Pluto got kicked out of the Planet Club and is now considered a dwarf planet. But don't worry, there's quite a few dwarf planets out here in the Kuiper Belt region. We've got Makemake, Hermes, Aries, and of course, closer to home and the main asteroid belt, we've got Ceres. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now on our screen, folks, I'm going to be adding some of the many different spacecraft that we sent out in the 1970s to explore our solar system. So on screen now, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction on the very top left right there, where they cross paths. Oop, actually, it was that one right there. Oh, it's one of those. There they are. But also, folks, all these spacecrafts are traveling fast enough to escape our sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for light to travel all the way out to the orbit of Pluto, takes light about 5 hours at the speed of light. So again, 5 hours only get to the orbit of Pluto. That's not that far at all, to be honest. But folks, let's leave our planetary scale behind us because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And I just want to make sure I'm looking at the right star system, just giving myself a quick twirl around. So yeah, it's going to be the one on the left that just passed in front of us. So we're right in the middle of the screen. On all the way on the left, we're going to see Alpha Centauri. That's the closest star system to us. And again, 4 years at the speed of light to cross that distance. That is really far. But that doesn't really put into perspective of how long it would take us humans to travel that distance in a rocket ship. Well, if we were to get in a rocket ship today, left planet Earth, head over to the next star system, it's going to take you about 8,500 years to cross that distance. And that's just a one-way trip. Whew, that's a long road trip. But, folks, let's stop and consider whether humanity has made its presence known beyond our solar system because now we're going to be stepping inside something called the radiosphere. So, again, we're now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signals, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they travel at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody listening? And folks, right now I'm going to be adding on screen some of the many different markers that indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth like with conditions suitable for life as we know it. So far today, we found 5,000 exoplanets in the nearby vicinity to us, 5,000 other planets outside of our solar system. Whew, that's a lot. But that 5,000 number is going to be increasing because we have space telescopes where their whole purpose is to find as many exoplanets as possible. So they're constantly scanning that night sky. But to answer if any of them are Earth like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much new spacecrafts are being developed right now for that purpose. So it's going to be a few years before they launch, and then we can tackle that question head on. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system. Let's say this one right here. We find an alien civilization all the way on the right hand side, let's say 60 light years away from us. We shoot them a text message, takes 60 years to get to them. They listen in, answer back another 60 years. Well, that is a 120-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But I want to put away our exoplanet markers, because that's a whole lot again. But I want to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, folks. So again, we're now looking down at our Milky Way galaxy, and can anybody see their house from here? Just kidding. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross our galaxy from one side to the other, it's going to take you about 130,000 years at the speed of light to cross the Milky Way galaxy. Whew, that is really large. And not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be potentially billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I do want to show you it from a sideways perspective. So we live in a flat spiral disk of the Milky Way galaxy. And when you look up in the night sky, you may have heard people say, hey, look, there's the Milky Way. I can see it. Well, they're referring to this plane that we're seeing here. This is what you would see up in the night sky. That's the Milky Way. Now, this is great because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, stuff that blocks their view of the universe. So keep that in mind. Astronomers like to point their telescopes galactically north or galactically south. That's going to come important a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy, each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies, voids in space. So we can see a nice galaxy cluster off to the right. We can see a galaxy in the middle and the back. We can see very few galaxies towards the top or voids where there's no galaxies at all. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far back now that this picture that we're looking at represents the closest 30,000 galaxies to us over a space of 300 million light years. And this was all created by an amazing crew led by the astronomer Dr. Brent Tolley, who worked at the University of Hawaii. So big shout out to Dr. Brent Tolley and his crew who worked over decades of time to create this galactic map. But now we have automated systems that are mapping even the most distant galaxies because now, folks, we're going to be looking at the large scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And just a heads up, folks, the large scale structure of the universe is not shaped like a bow tie or a butterfly, although it kind of looks like it right here. Remember when I mentioned that we live in a flat spiral disk of the Milky Way galaxy? Well, if we were to line up our Milky Way, it would line up just down in the middle, just like so. So, again, we like to point our telescopes galactically north and galactically south instead of looking to that plane of the Milky Way. But astronomers still look through the plane because they want to make sure they were still able to find galaxies. And you can see this purple survey right down in the middle. You'll notice that they were able to find galaxies, just not as far and not as many. Pretty much, we have to wait for our technology to improve, advance. And once that happens, we'll be able to map out the areas that haven't been mapped out yet. So you can kind of think of all that stuff on the right, but in every direction that you would look. So it's just a matter of time. We just got to wait for that technology to be developed. But folks, looks like we're running drastically low on our time. 30 minutes is just not enough time to talk about the universe. So let's continue pressing on because now we're going to be heading to the edge of the large scale structure of the universe. And we're going to be coming across these objects known as the quasars. And the quasars are going to be represented by these nice orange dots at the very edges. We can see them on the right and on the left. And the quasars are short for quasi-stellar radio sources. And these blazing hot objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, well, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, so here we are at the very edge of the observable universe, and what we're looking at is something called the cosmic microwave background image, or the CMB image for short. All evidence indicates that the universe we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, it's a temperature density image where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny, and they vary no more than 1 part per 100,000. But these very tiny differences gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies, and let's fly back to planet Earth. Alrighty, folks, we're crossing the expanse of 13 billion light years, and we present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're making our way back to our Milky Way galaxy. We're heading straight for that radiosphere. And of course, we're making our way downtown, walking fast faces past and we're homebound. Da-na-na-na-na-na. And now we're approaching our star system, folks, our solar system. We're passing those spacecrafts we sent out in the 1970s to explore our solar system. And we're making our way to the third rock from the sun, our homeworld, the only place we humans have ever called home. Everyone that you know and love all existed on this one planet. And it looks like we're passing the orbit of the moon, the furthest we've ever sent humans out into space. And with that, folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But with that being said, looks like we're back home safe and sound. And that's all for now, folks. Thanks for stopping by.